Hello everyone, my name is Avani Vaidya and today I'll be giving a presentation on the project week 1 for the course of CE570 Advanced Structural Mechanics. This is an introduction to the MATLAB programming. These will be the table of contents. So the first will be the overview of the object, followed by the parameterization of the sphere, which is my chosen object. Third will be the MATLAB output, which constitutes of the plotted object output and length and area results, followed by the manual computation, and lastly conclusion and remarks. Overview of the object. For plotting in the MATLAB program, I've chosen sphere as my object. It's a three-dimensional geometrical object that has all its surface points equidistant from a cone. That's how we can define the sphere in mathematical language. Now, this is the parameterization of the sphere. For curve C, we use one parameter and which is given by r cos phi, r sin phi, and 0 over the range of 0 to 2 pi for the phi. And for surface, it's given by r sin phi cos theta, r sin phi sin theta, and r cos phi, which ranges from 0 to pi by 2 for phi and 0 to 4 pi for theta. This is the MATLAB output for n equals of 10 segments, which is presented by MATLAB. Okay, so output results are given by MATLAB and the ones I calculated. So for n equals 10 and r equals 1, where n equals number of segments, the length of the curve is given by 6.1803 and area of the surface is given by 12.0096. And if I just compute the same results with hand with a theoretical formula, it gives answers that length of the curve is 6.28315 and area of the surface is 12.5663, where we can find the length of the curve by the formula 2 pi r and area of the surface by 4 pi r square. There was found a percentage error in computing, which is the difference between the MATLAB program computation and the manual or the theoretical calculation. So there was a percentage of 1.63% difference for n equals 10, and in area there was a 4.4304% difference compared to the actual or the manual calculations. These are the manual calculations that I prepared to check whether my answer is right. So we know that for the length of the curve L, we need to integrate the dl with respect to the certain limits, where we take the magnitude of the dx by d phi times d phi. So after getting all that, we get the magnitude as r, and next is we get the length of the curve as 2 pi r. And from the MATLAB input where I put r equals 1, I get the length of the curve as 6.283 units, which is the actual or the theoretical length of the curve. Now these are the calculations for the area of the sphere or the surface of the sphere. I used the parametric equations that were given in the previous slide, and then I double integrated with the magnitude of the dou x by dou phi cross dou x by dou theta times dou phi and dou theta. So after getting all that, I have computed that my area of the curve becomes 4 pi r square, and the actual area computed becomes 12.566. Now conclusion. So what we saw from this is that the number of segments in the curve increase And when that happens, the percentage difference between the actual value and the approximate output of MATLAB decreases. So what that means is basically that when we increase the total number of segments, when we're defining a curve, the MATLAB program actually approximates the integration more closely, which means that when there is like the greater number of segments, it gives more accuracy. So if you see the following table, we can see that for the value of n equals 10, the length is 6.18, and for 100 it's 6.28, and for 1000 it's 6.283, which is really close, or like almost close to our exact value. And even is the case for the area, where for n equals 10, the value of area was 12.009, but for n equals 1000, the area was 12.5563. So that's my conclusion, that as we increase the number of segments, we go to more accuracy. Thank you.